Hey everyone. At the end of today's lecture, a student asked me, how would we actually go about implementing let in the Lambda calculus, for example? And this is a pretty good question because in the Lambda calculus, everything is a function, but let seems to behave a little bit differently than just a regular function because it first binds values to names and then uses those names later on. However, there's a very simple idea that allows us to convert let expressions into regular old function expressions. And the simple idea is this. If our goal is to achieve local scope, like let does, then pure functions already have this because of their parameters, which are local to the body of the function. And so if I want to take this let statement, where x is bound to 5 and y is bound to 10, into a function, I can simply write the equivalent function lambda xy plus x times 2 and 3 times y. Take this function and call it on arguments 5 and 10. And hopefully when you see this, you realize that these two are exactly the same. Over here, we take the body of the let expression and substitute the values 5 and 10 for x and y. Over here, we know that function evaluation is simply substitution. And so we take these arguments, 5 and 10, and sub them in for x and y in the body. So if we run this code, we see that these two give the exact same results. And this is how you can implement local scopes in the Lambda calculus. And by the way, understanding this equivalence makes it also easier to understand why let doesn't allow you to refer to previous bindings. If we wanted to bind y to the value of 3 plus x, then what that would translate to as a function call would be we'd replace this 10 over here with 3 plus x. And now all of a sudden, we have an expression where the x is undefined because the x parameter is only in scope in the body of the function. As I said in lecture, we can get around this problem using let star, which is basically a series of nested lets. But I'll let you think about that. Thanks for watching and have a great day.